Nature has inspired humankind, not for decades, but actually for centuries. Nature surrounds us, and that's why it inspires us so much, and that's also why it has inspired me so much.
Biomimicry is the conscious emulation of nature's genius. It's turning to the natural world and asking, how have you learned to live here so well, and what can you teach our species about how to be better fitted on the planet? Just like this forest, life depends on water. So there's no shortage of things that we can learn from life on how to process water, take care of water, store water, manage water. And there's huge potential for thinking about how do we better take care of the water that we put in our bodies, that we use in our systems, by looking at how nature manages water.
Most of the things you do in your daily life actually use water as a resource. But today, around 80% of all industrial wastewater is put into the environment without adequate treatment.
PFAS is short for perfluorinated alkylate compounds, and they are incredibly useful in industry for multiple purposes. The trouble is that we are now seeing the results of this widespread use for decades. And that means that our pure drinking water is contaminated by industrial chemicals that nature has never seen before. They are man-made. That's not so good, because that means that when we're exposed to PFASs, they get into the body, we can't break them down. And therefore PFASs tend to accumulate in the body over years, and likewise in the environment.
The company name Aquaporin is actually also inspired by nature, because in nature we have this protein that filters water in all living cells that is called aquaporin. It is a protein that was discovered by American Nobel laureate Peter Egre, who got the Nobel Prize for that discovery in 2003. We then founded Aquaporin in 2005. The aquaporin protein is sitting in the cell membrane of all living cells. Without the aquaporin protein, there wouldn't be life on Earth. What it does is that it's sort of a swing door for water molecules to go in and out of living cells. And it's only water that goes through these water channels. It does so very, very efficiently. So one aquaporin protein can filter 1 billion water molecules per second. It means that 1 gram of aquaporin protein can filter over 700 liters of water per second. So that's the aquaporin protein. If you then look at the Aquaporin Inside technology, we use that as the building block to coat the surface of more conventional membranes. The Aquaporin Inside technology essentially filters out all things in your drinking water. It filters out viruses, bacteria, but also all the inorganic compounds that we don't want to have in our drinking water, like pesticides or PFAS. We can use the Aquaporin Inside technology both for water filtration, which is the more classical way of filtering water, and we can also use it for water extraction, which is essentially the process that comes closest to nature. And in this experiment you actually see, just by placing the Aquaporin Inside membrane on top of the dirty solution, you can actually see how selective the membrane is in extracting pure water out from a dirty solution. The way that we got the conceptual idea of using the aquaporin as a building block for a new technology is a good example of how biomimicry works, because it was given to us by nature, so to speak. It is something that has been developed through 3.8 billion years of evolution.
What Aquaporin offers is a really great example of following those best practices of biomimicry and the methodology, abstracting that design principle and scaling it so it can apply in the industrial world.
On a global scale, there is a growing need for new technologies and for water treatment in general. And being part of the solution to that is a big motivation for me.